Do this question. Find the current through the 5 ohm resistor. Okay, so here in the circuit there are 1 2 3 4. There are 4 meshes, right? So which means there will be 4 mesh currents, I1, I2, I3 and I4. Okay, so now let me mark all the mesh currents as usual. Okay, and I'll mark it with a different color so you can see it very clearly. So this is the first mesh, so I'll mark this as I1. This will be the second mesh, so I will mark this as I2. This will be the third mesh, so I will mark this as I3. Okay, and this will be the fourth mesh, and I will mark this as I4. Okay, I1, I2, I3 and I4, right? So now I'm going to apply my mesh analysis to each and every mesh. Okay, so if you right now itself you can already understand this question is very easy because there are a lot of current source on the sides, right, on the side branch. So let's do this problem. So first I'll write the equation for mesh 1, the equation for mesh 1. Okay, the equation for mesh 1. So here this is the mesh 1, and we know that the current across this branch is I1, but in that same branch there is a 4 ampere current source, which means the current through that branch is 4 amperes. So which means I1 is equal to 4. Therefore equation for mesh 1 is nothing but very easy. It is nothing but I1 is equal to 4. This is the equation for mesh 1. That's all. Now let me write the equation for mesh 2. Equation for mesh 2. All right, so here mesh 2 means I2 is positive and the remaining currents are negative, right? So which means the current over here is this I1 is touching this one, right, this 5 ohm. So it is minus 5 I1. Okay, and then what about I2? I2 is touching this 5, this 2 ohm and this 2 ohm. So 5 plus 2 7, 7 plus 2 9. So it will be plus 9 I2. Okay, 9 I2. And what about I3? Well, I3 touches this 2 ohm resistor over here, right? So it will become minus 2 I3. And what about I4? Yes, I4 is also touching this 2 ohm resistor over here, so it becomes minus 2 I4. Okay, see, so this is mesh 2 current, right? Mesh 2 equation. So mesh 2 means I2 is positive and the remaining currents are negative. That's what it means. Is equal to, and is there a voltage source over here? Yes, there's a voltage source. There's a 2 volt voltage source over here, and this current I2 is flowing into the positive terminal, which means this positive terminal is not generating current, it is opposing I2, which means this is minus 2. Okay, this is minus 2. I'm not going to substitute the value of I1 over here because if you look at the remaining currents are also having the same kind of problem. So I will substitute the values at a later stage. Okay. So now I'm going to write the equation for mesh 3. So the equation for mesh 3, right? So in this equation for mesh 3, this is the equation. So here the current I3 is given over here, and in this branch I3 is flowing downwards. Okay, but according to your question there is already a current source 3 ampere which is flowing upwards, right? Means the same branch there is a current I3, and the same branch there is that same current is 3 amperes which is flowing upwards, which means the equation for mesh 3 is nothing but I3 is equal to minus 3, right? This minus sign is here because the value of the actual current is opposite to the one that you have assumed. You are assuming that there is a current I3 which is flowing downwards, but there is a current source over here which shows that the current is flowing upwards. It means that current is flowing upwards, which means it is leaving with 3 amperes, and that same 3 amperes finally gets back into the current source, right? So this 3 ampere current source, but according to your assumption, that same current is called as I3, which is flowing in the opposite direction. That is why it is I3 is equal to minus 3. Okay, and the equation for mesh 4 is equation for mesh 4 is nothing but, let me see, so this is the equation for I4, right? And here also luckily there is a current source over here this side, right? In this branch the name of the current is I4, and in the given question also there is a current source, and that current source is leaving with 3 amperes, which means the same branch is having 3 amperes and the same branch is also one that is flowing with I4 ampere, which means the value of I4 is nothing but 3 amperes. I4 is also equal to 3. You see, so I1 is equal to 4. This is the mesh 1 equation, and mesh 2 equation is this one. Mesh 3 equation is I3 is equal to minus 3, and the equation for mesh 4 is I4 is equal to 3. That's it. So what I'm going to do is, I think I'll substitute the value of I1, I3 and I4 in this equation. So which means I will get minus 5 into 4 plus 9I2. What are we supposed to find? Find the current through the 5 ohm resistor. Where's the 5 ohm resistor? Over here, right? This is the 5 ohm resistor. So which means the current through the 5 ohm resistor is I1 minus I2, or I2 minus I1, depending on the value of the current, right? Which one is greater. So it can either be I1 minus I2, I2 minus. So that's what we need to find. So which means I need to find, already I1 is given, which means I need to find I2 also. So let me find I2. So minus 5 into 4 plus 9 I2 minus, and what's the value of I3 is minus 3, right? So minus 2 into minus 3 minus 2 into, and the value of I4 is 3, is equal to minus 2. And this is minus 20 plus 9I2. This is plus 6, right? Plus 6 minus 6 is equal to minus 2. This 2 will get cancelled. 6 minus 6 is 0. And this is 9I2, right? So this is 9I2 is equal to 20 minus 2. 20 minus 2 is 18, which means I2 is equal to 18 by 9, which is equal to 2 amperes. Therefore, I2 is equal to 2 amperes and I1 is equal to 4 amperes, right? So which means I1 is equal to, which the current across this branch is for current is I1 minus I2. So the current through the 5 ohm resistor is current through the 5 ohm resistor is I1 minus I2, which is equal to, I1 is nothing but 4 and I2 is nothing but 2, which is equal to 2 amperes. It's positive. Positive means, why it is positive is because I1 is greater. I1 is greater, which means the current is flowing downwards, right? That's what it means. So 2 amperes. This is the answer.